So I'm going to tell about QuickCheck and not so much about the technical content of QuickCheck, although I want to do a demo and I hope that that will work, but more how we got from an invention to a product. So if you look at the website of Curion, then the main phrase there is academia and industry, they need to talk, right? And then the question is why, right? That's the obvious question. So this is the question from me to you. Why do we need to talk?
So that we stop doing so that we stop doing irrelevant research.
Okay. So that
that's a
doing
joke.
Irrelevant research, right?
Oh.
Right.
In general, I think that a lot of good things are invented in academia that are widely ignored, and a lot of useful experience comes from people working in industry that we ignore. So, and then we could do more socially useful research or find better ways to apply the things that we've done if we have talks with the right people. That's my take.
Okay, that's a good take. Anyone else that wants to say something about this? Has an idea of why on earth academia and industry should talk?
I think in my work, I sometimes, coming from industry, I'll read a paper and having more occasions, it's like people go to WWDC to yell at the developers who make their life miserable, or tell them so having more opportunities to talk to academics who are writing the papers that perhaps influence my work, and be able to say, well, actually, what I care about is this. I really care about what you're doing, but also, perhaps this aspect would be really interesting. I think that would be sort of an ideal scenario, and something that I do hope for.
I like that answer a lot, because it gives this interaction in a nutshell.
In the industry, sometimes people miss the vocabulary to talk about software. And I think this is the main reason why many developers just say, I like this, you like that, so let's stop discussing about it, because the vocabulary is missing to quantify and to describe software. And I would have loved to expand my and my teammates' vocabulary and have better chances of talking about software.
Oh, I like this vocabulary thing. I will come back to that in a slide in a minute. Anyone else, or shall I continue what I think?
Can I raise my hand?
Oh yeah, oh sure. So we are, for those that are coming in now, we are answering the question, why on earth should academia and industry talk?
The only thing that I was going to say is we at Basho implement CRDTs, which is largely an academic invention, and implementing this stuff is really hard. Getting it right is really hard. And yeah, we need to talk together. That's the only way we've been able to do any of this stuff and get any of it working, so.
Okay. So I jump forward then. So my main reason to do this, to say, why should we talk this? Because of innovation. Innovation is something that needs both partners. Innovation is not done in academia. That's for sure, because that's inventions which are done there. An invention gets an innovation if it is used outside, right? That's what we call innovation. So for the reason of innovation, we need to talk, and we need to go and talk to each other. And I will tell the story of one of such an invention going into an innovation, and that's QuickCheck. And for those of you who have never seen QuickCheck, I will give you a very short introduction and then a little bit longer demo later on in the talk. So QuickCheck, the idea of QuickCheck is that it is extremely boring to write test cases. Okay? That's something people don't like to do, and people do very poorly, and it's also, some part of it is creative, but a lot is very uncreative. So you want to move testing from this uncreative, kind of robotic job into something smart. And the way we can do that with QuickCheck is to generate your test cases automatically. So instead of writing, you have the computer make your test cases. That sounds fantastic. It comes with a price, of course. Nothing for free. The price is that you have to write a property. You have to say a property about your software. Like, the software should not crash. That's a property of the software. You can think of lots and lots of properties. I will show an example later on. but you write a property about your software. That property is now central for automatically generating test cases from. So this property is given to QuickCheck, and QuickCheck then says, oh, I generate a number of test cases, and oops, I have a failing test case here. So this test case generation is done on the basis of randomness. There's a random process of creating data that feeds this test case. You have random test cases, and one of those test cases may fail. Now, failing test cases are normally the things that testers really like, whereas developers prefer to have the non-failing test cases. That speeds up their work much better. So you have a failing test case, but since this is randomly generated, such a failing test case could have lots and lots of data in it, or lots of things in it, which are not really relevant for making the property fail, but which are there anyway, because you have this random process. So what we do then is automatically simplify that test case to the simplest possible test case, a minimal test case that provokes a failure. Right? So now you have your debugging. So normally if you get a log, for example, oh, something went wrong, my system crashed, here's the log. That's kind of brain dead, dumb work to go through the log and find out what has happened. Wouldn't it be fantastic if the log is automatically decreased to 5 statements saying, hey, this is where your program goes wrong. Now that's what we do with QuickCheck automatically. And we do that in order to get the real signal out of the noise that you get when you put randomness in the generation process. So that's QuickCheck in a nutshell. I will give you a little example later on. This invention of QuickCheck was published in the year 2000 by John Hughes and Koen Claassen, both from Chalmers University in Sweden, in Gothenburg. They wrote this in Haskell QuickCheck, and they presented that at ICFP 2000. Later on, 10 years later, they got the prize of most influential paper of that conference, because it really spread well. The first paper, look at this, and come back to the vocabulary that you mentioned before, right? You said, oh, I want to learn some vocabulary. Can you see some vocabulary here that kind of, if industry reads this, would say, ash, not for me? Haskell, yeah. Haskell. Monad. Right.
There we are.
Next one. Random. That's true, but there was one in between. Formal specification down there. Not something really industry likes. Randomness. Not really nice. So lots of words in there, which for one or the other reason, and particularly in the year 2000, you remember Haskell has evolved a lot in the sense of adoption. But in the year 2000, Haskell was really, that was the ivory tower, that was the Haskell thing. So, yes, lots of words those days that would scare off industry to go on with that. So, oh, this is a pity. It's a bit, it's nicer on this screen. But anyway, so there's this Haskell invention here, right? This is the olive mill. You can have delicious olive oil if you put it in that mill. And then there's the money-making world on the right without any mill. And there's some cities here, but there's no mill, right? But this is this invention, you can make olive oil. And fantastic olive oil, actually. So, delicious, very good. But it's stated in academia in this way, right? So, how do we get it out of this Haskell monad world and make it applicable anywhere else? Suggestions?
Monadic return.
Monadic?
Monadic
Return.
return.
Yeah, you add an extra word to the monadic, and then people say, oh, right, this is great. Yes, so that would be a way. Yeah. Fantastic. But people are scared of that. So, and they were scared even more that time. So how do we kind of get that out?
Use it in practical functional language like Erlang.
Fantastic. You are 2 slides ahead. Fantastic. That's one way of doing it, of course.
Write a JavaScript implementation.
Write a JavaScript implementation, also something we've thought about. Yes. What else can we do? So there are lots of things that you can do. You can also say, well, let it stay in academia. Why would we want industry to use this at all? It's far too nice, right? Why would we bother people in industry working with this? We are going to make people unemployed. lots of testers will not have a job anymore. So that's bad. We will give pleasure to testing, which is not good because then you can't punish bad developers to do the testing. So it's kind of not nice to do this. So let's keep it in academia and make a pathway through. That's another option that you have. And you can have the option of doing it in Erlang and make people adapt and adopt this and grow from there. So that's the thing. So one way of getting industry interested was doing it in a different language. JavaScript wasn't around at those days. I think at least I hadn't heard in 2000 about JavaScript, so it probably was around, but Java was the big thing, of course. We need, in order to implement QuickCheck, you need a lot of functional primitives, higher order function, things like that. It was simply not going to be done in an imperative language like Java. So Erlang was kind of more normal choice of it. In particular, since I had an Erlang background, I come from the computer science lab from Ericsson, it was kind of natural for me to do this in Erlang. But it all was kind of based on simplify, right? You have to simplify it, because in Erlang it would be simpler, there would be no monads, right? And there was kind of a culture and adaptation, and we all believed in those days that if you have this delicious olive oil, and you make it simple to produce it, then people will take that for dinner. Now I know better, but that was kind of the idea that we had in those days. So, what did we do? John and I wrote QuickCheck for Erlang. That was fun. It was really fun. We had a good time. And then we said, let's go to the ElixirConf and present it. And this is the second or the third slide. In retrospect, right? Was probably not the best slide to present, but hey, a little set theory, right? You imagine this is 150 people from the telecom industry sitting there. Okay? You all know what set theory is, you say, right? Anyone not familiar with set theory? Okay, so set theory is basically the theory about sets. Right? That you have elements. No, it's a valid question. Come on. Set theory is something that, talking about vocabulary, right? If you have sets, you can have disjunctions where you look at what the differences in the sets is. You can union the sets. And there's a theory around what all this should boil down to. So, in set theory, you have a number of axioms, and it says, if you take the union of two sets, so if you combine two sets, does it make a difference if you combine them one way or the other way? That's what set theory learns us. Erlang, at that time, has a set library. It still has a set library. It hasn't changed since then, I think. And in this set library, you could ask yourself the question, does that property of the sets hold? Right? If there's a union operator, does it hold? In normal logic, secondary logic, or predicate logic, you could write something like, for all x, which are sets, and all y's, which is another set, if I take the union of those two sets, and I take the union the other way around, then it should better be the same. Fine? Everyone agrees there. As long as you know a little bit about set theory, you would say, well, that makes complete sense. So we would now like to test this, that this holds for Erlang. What can you do then? You can write three test cases, the empty set and some non-empty set, and you turn that around. And you can do it for, say, a set with 2 elements, and you take a set with 5 elements. And then you're really, really bored, and you don't do anything. That's how testing works, right? And what kind of elements do you take? Well, you take 0 and 1 and probably 7, because that's very random 7. And 42, because everyone used to 42. So you make those kind of tests, and then you write this property. And I wanted to demo you how that looked like. So this was what John was presenting at that Erlang user conference, and he showed the following demo, approximately. The QuickCheck version we had then was slightly different, but so this. Let me first show you the code. Here we are, slightly larger. It's really almost direct, right? For all sets S1 and another set S2, you should have equality between the union of S1 and S2 and S2 and S1. And this sets library is the implementation, the Erlang implementation of the sets. And how do we get sets? Well, now we know better, but in those days, you took a list, an arbitrary list of integers, and then you applied the sets from list operator to it. And this is what we call a data generator. So QuickCheck consists of properties, and properties need data generators to generate the data, and then they can do something with that data. So this is what is happening here. So now we could kind of try to see if in Erlang this property holds in the sets library in Erlang. So what we do is we compile this code, and that works fine. And then we can do a sample. There's something called ElixirConf sample, where we can have a look at 1 or 10 or whatever. I can do 1. I can pick one example of a set. So this gives me a random set. And the set has 3 elements, but this is the internal representation of sets. So I normally don't want to see this, but the Erlang sets representation has an internal representation. It has 3 elements, 0, 3, and -3 there at the end, right? And there's some other kind of bookkeeping variables and lots of lists in there. It's pretty awful. So this is another one. It has 2 elements, and you see it's -5 and -3 over there. So this is how Erlang internally represents sets. So let's run the property then that I wrote. So running the property means generate 100 random test cases, 100 random sets, or actually 200, and combine them in the property. Say, is the union indeed the same? And what you will see, oh, this was very fastly. So what you see is that it passed 78 test cases. All the dots are passing test cases. But then we failed. And this is the failing example. So we have this set, which is the internal representation of that set. We scroll down a little bit. We have another set. And then we have a lot of junk here saying that those sets, the unions are not equal. They are different, right? And then you see a lot of crosses here. And this is where we try to make that counterexample smaller. So we make a smaller example of what goes wrong. Okay? And then we see the smallest counterexample and why that is not correct. And it's hard to read, but the idea is here, in the internal representation, those things are not equal. So they are equal if you would have an equals operator in the sets library, then it would work. But there's still no equals operator in the sets library, even though we showed this in 2005. So people are not using the sets library, right? It's not important. It's a fun thingy to have, but why would you use that? There's org set, there's all other kind of things. People simply don't use that. So that's the other thing. So now you've seen how it works. Oh, I just wanted to make one more demo thingy here. So we saw that in the talk, those of you which were on Zach's talk just before, we saw that the macros and all that stuff is fantastic stuff. To create programs. We can equally well as picking a random set, we could pick a random Erlang program. So we could do EQC Erlang program. There's a generator for a module of, well, my-mod or something like that. So I make a new Erlang module. And I will see, poof, this is Erlang code. And it's not very nicely written, so I can make a string of it, and then you can actually read it because all the new lines here. So I can make this into a nicely formatted one by doing it approximately like this, printing the string. So here we have a randomly generated Erlang program. And it is compilable, right? This program compiles. It's a bit strange, the program, but it should get through the compiler. So this is another thing you can do with generators. You can generate all kind of data. Okay, so that's good. Let's go back to the presentation. So after this demo, after that you learned about set theory, how do you feel about this invention? Is this useful for you? Would you say, yes, I take this home, I will start using it immediately?
Yes.
No, I see a no there. Right?
I have been using it.
You just said that they don't use the set library, so why would they care about this result?
So this is a very good remark. It was probably not on the mic. The remark was, why they don't use the set library? Why would they care about this result? Yeah? Why would they care about this result?
Well, hopefully they'd see past this solving set issues, with testing sets, and possibly see the potential in removing tons and tons and tons of brain dead tests over in their code. Hopefully, but I don't know where history went.
The history goes, so the idea is just that they should see that this is actually just an example. This is not the only code we can test. But the conception very often is, oh, fantastic, they can test sets, but we don't use sets. So it's not useful for us. And I've seen this over and over and over and over again. No.
I think also you might have the impression that this isn't useful for testing imperative programs, and that it only works for sort of the functional subset of the pure functional subset of the language, which you may not care much about.
Exactly. So thank you for that observation as well. So what we did, of course, say, look, guys, testing concurrent software we can do as well. It's not just this pure part. So in the same talk, John then starts defining a little server which has a number of functions, a resource locker. It starts a server, it claims a lock, and it can free the lock. And this is on slide 25 that he says, oh look, we can have this server, and then he explains all the kind of things. And then in the right corner on slide 35 you get the property, right? That property is hard to read, but it doesn't matter if I make it larger because you won't be able to read it anyway. It's a bit too complex somehow, right? There we say, okay, we can do it. We can show that we can do it, but the property you have to write may kind of scare you off. And it did. It really scared people off. They said, oh, this is fantastic, but it seems not usable because I don't have a resource locker. I normally write different software, right? It's hard to get the message over. So what we try to do now is we had this invention, and we have this money-making smaller world, because the Erlang world is much smaller than the real big world. There's less money, but who cares, right, if you get part of that. So we made a bridge to this smaller world. And we thought, oh, this is fantastic. We open sourced it. We said, look, use this stuff. It's great stuff. This is the reaction of industry. It was not used. It was not used because there's no need to use this. We don't have sets, and we don't have lockers. It's simply not very usable. But moreover, we don't have a problem that this fits to. And that's key, right? The need of something. Is there something that fits? And any one of you experienced this? Why would we need to change? It works as it is. Yeah?
In my experience, it's not so much that I don't have a need for it, is that it's very difficult for a non-trivial application to come up with the properties to express what I want to test.
Difficult. Simplicity is the key here. So it's hard to see how this would apply in your field. And if it applies, is it worth the investment that we have to do to get there? So that's a problem. So, okay.
One thing that I'm frustrated with is, for example, I do a lot of web programming, and it is MIS pattern that has just established itself and you can't get rid of it, is persistency testing. And what you're doing is you are setting up a database, you are doing stuff in the business logic, and then stuff gets saved, and then you go like, okay, this object and this object should be in the database now. And this leads to all kinds of problems. It's difficult to write, it's difficult to test. But even if you do it, you're not doing it properly, because you're not you're testing real toy cases. We just store a very small subset of what you're going to do on live production. And I've discussed this idea many times with my colleagues, where you go like, you try to discover a space of what's possible, what could happen with that code. What if the user does this? What if the user does that? But it never happens. I don't know why. Maybe because people are frightened that it might find a bug while they're still developing the code. Yeah.
Thanks for the observation. So there's lots of different scenarios that you have to test. And that is normally not covered in normal testing, even though people probably want to. It's not taken up on because they are scared for the work, probably the workload or what it involves. Right. So, although, though, QuickCheck at that time wasn't really taken up by industry, we do see research really actively doing some things with QuickCheck. Even the Erlang QuickCheck version, the Haskell QuickCheck version has its own trajectory, lots of publications out there, very nice stuff to read. But also in the Erlang side, we did something. And among other things, Hans Svensson, he verified with QuickCheck, or tested with QuickCheck, the leader election implementation written by Ulf and Thomas. There's much more in this thesis, that's just part of it. But he did formal proofs and he did all kind of model checking stuff, etc. But Ulf and I, we wrote, when I was still working at Ericsson, we wrote a leader election protocol for distributed systems. And he tested that with QuickCheck. And we told Ulf and we showed him the results, and that had a good impact. So that had as a result that Ulf Wieger got really convinced that this was cool stuff. And he went to his management and said, oh, we should try this. It's an open source product. And the management said, oh, no, we are far too busy to try these kind of things. They changed the policy. They had this telecom life cycle where they had one release every 1.5 year approximately. And now they had to have 7 releases in a year. And they said, oh, this is probably a familiar picture for you, but at the end you detect lots and lots of errors constantly, and then your errors drop, and then somewhere here you release the product, and then by the time the customer is using it, you're here, right? So very kind of hard thing, and they said, we have to get rid of it, because we have this development project, and it's not an agile project. We can't do it anymore. Testing is always kind of the problem, because testing is at the end. And if we do testing at the end, we will find the errors at the end, but we can't squeeze that. We can't say, oh, let's find less errors. Yeah, we can do that, but it doesn't really work. So, and he was convinced that QuickCheck would help him there. So that's good. So we had an advocate in the industry, and to make the story short, he said, okay, let's come to us and implement this stuff. And let's do this on a real product. The media gateway is a kind of SIP telephony that they had. They had a media gateway. Let's test that stuff because we are hopelessly behind schedule. So guess how much specification such a media gateway. A media gateway is a very simple thing. So you get the telephone call in. It has an IP address. You say, okay, that IP address may go through. Oh no, that IP address may not go through. That's basically what it does. That's a gateway, right? So how much specification do you think that kind of system has? Okay, auction, 20 lines of code.
6,000.
6,000 pages.
Pages.
Oh,
Code.
that's a bit too much, but you're close. You're close.
Okay.
It had 212 pages, so that's very small for telecom. Very small. But on top of those 212 pages, they had 183 pages Ericsson internal kind of adaptations of the protocol. So, fine. The control software of the whole thing is 150,000 lines of code. Erlang code. It's like, wow. So we said, okay, he called us, said, come to Stockholm, help us, we are in trouble. So we went to Stockholm. John and I sat there 4 days, and we tested the stuff, and most of the time we discussed the errors we found, and most of the time they said, oh yeah, we need to fix that.
Thomas, you're out of time.
Sorry.
Are there any questions before, or should we just let him continue? Any questions? Continue? Okay.
So we came down to the conclusion that while doing this, what they really needed was not the olive mill, because they have microwaves there, and they need power for the microwaves, right? So we made a completely different mill that gave them what they needed. The EQC state that's a state machine specification language for these kind of problems. But what I wanted to go to is that this is fun, because now we had actually the possibility to write another article really applying QuickCheck on real examples. And this is a very well-cited article. It was published in the Erlang workshop, but that besides, it was really nice work. And there is no monads in there anymore, and no Haskell in there anymore, although that wouldn't work. There's words that they like reduced testing time, observe obscure bugs, product quality, industrial implementations, right? That's kind of things. And I also wrote another article with other people from academia about the cycle of when inventions are potentially successful. So we had lots of data of other projects that we started, and we could, from this data, kind of derive a model in what is needed to make an invention into something that has a sustainability inside companies. So that's also kind of nice reading. I will not go through it. But it resulted in us having a very strong application for the EU, in the EU project, FP7. So if you think of as a researcher, this is great, because now you have shown that you're applicable, you can get research money. That works. And we got a lot of testing challenges from Ericsson. We extended QuickCheck for testing concurrent systems instead of just kind of the normal systems. And then we validated our IDs with, for example, companies like Klarna and Basho. And that was very, very nice. So as a company, Cubic company, it was nice that we could enter new markets by offering them the things that we did research on. But it's also very much this innovation motor which is going on. Because we talk to industry, because we get the problems from industry, because we can do the cool challenges from industry, we actually meet people at industry, we talk to, we can publish, and we can get new ideas going. And one of them is this article at ICFP in 2009, where we present Pulse as an example of that. How much more time do you have? Okay. Any observations, questions directly from here?
So I'm wondering, how do you, I don't know if you know this, but how well do you think the concept of fuzzy checking, quick check in general, how well has that penetrated outside the realm of functional programming languages?
So the question is, how much fuzzy checking is there around? It depends a bit on how you define fuzzy checking. Lots of people do random values in their test cases. They just call the random function and they make something up.
Right.
Is that fuzzy? Probably not. But in the C world, that's quite well done. But otherwise, no, I don't really know how much it has taken up.
QuickCheck had a very rich life in academia and still has, and there are many successors like SmallCheck, all the symbolic execution and so on. Do you see any of these like trying to make a step to industry?
Oh, they all do. I mean, Facebook is using QuickCheck, and other companies are using QuickCheck. So really, a lot of companies do use all kind of open source versions of QuickCheck. There's QuickCheck for Java, there's QuickCheck for
I don't mean QuickCheck itself, but rather the successors that sort of criticize QuickCheck and try to improve upon it somehow, and so on, like SmallCheck, all the symbolic execution frameworks and so on.
So in my kind of view of the world, that's all the same technology to penetrate industry. There's, if you can't do that easier than with something else, it's still the same way of writing properties and getting on. So I think they all help to make this be adopted better. Some flavors are needed to get people tasty.
Thank you.
So it seems to me that in general, when you generate test cases automatically, the really hard part is how to. So what will be the expected results? So how to generate expected results or an oracle to test for that?
Yeah.
Could you comment on this?
Absolutely. So the examples I showed here are too primitive in nature. So what you really normally do in this property-based checking is you generate your test case according to a state machine, which embeds the oracle by encoded as post conditions. So the post condition of a call should be this. There's some internal state, and you could almost say it's a reference implementation, although on a higher abstraction level, testing against the real implementation. So that's your oracle that you have. The real difficulty in using QuickCheck is to write that oracle. That's the difficulty. And that's what a lot of people see as the barrier for adopting this technology. They say, how do I do that for my specific implementation? And what a lot of people do wrongly is they re-implement the same thing once more, which is normally not very successful. Yeah.
I may have missed this, but how do you test the specification?
So there's always this dispute of, yeah, but you just write your specification, then you generate your test cases. How do you know that your specification is better than the implementation? Well, you don't. But if you get a mismatch, something's wrong. It's either your test case or your implementation. Very often in the domains where we work, we have either people that know what it should do, or you can at least ask what you should do, or you have a paper, an RFC or something else, a spec, that you can relate to and can say, okay, this is an explanation of why our test case is correct, therefore the implementation is wrong, or the other way around. Equally often the other way around, where you say, okay, I have to adapt my specification.
So basically what you do is you write a spec, you write the code and check the one against the other both ways.
Yes.
Okay.
That's what you do.
If you found that industry is scared most of defining the properties up front, if they look frightening, if they don't know how to do it, I'm assuming your company can come in and help industry bootstrap some test suite by writing those properties initially and then hand over ownership to the companies afterwards. Have you found that helps adoption?
Yes, that's exactly what really helps adoption. So I have an example of the Volvo company making cars. They asked us, they are not functional programmers. They have lots of C code in the cars. They want to check that. And they come to us and say, look, can you help us write the specifications? So that's what we did. So we got from them a little bit of spec. And they said, could you please help us? There's a number of protocol stacks. We need to get this all right. And that's where we had lots of fun doing this stuff. And it's all written in C. And our QuickCheck then kind of generates C tests for them. And that's really cool because it was big, this project, as you can see from the specifications. And this is explaining a little bit how it works, but the good thing here is that you get another bridge. You get another bridge to the automotive industry, so that helps a lot. Where they are not interested in writing the specs themselves, they ask us, could you please do this? Because we don't want to do it. And there, again, this is a very, your point comes back. How do you, we don't know anything about cars. Apart from the color, I can't distinguish anything from a car. So, how do you know that your implementation is correct, your test cases? Well, you have your paper spec. You can discuss that. And a lot of discussion has come up in that sense. Yes. All in the back, Julia had a question.
Was there another question here?
So more generally, do you have a comment on how to make the transition from the stage where developers find your tool, they use your tool, they like your tool, and then make this transition from that stage to the stage where management wants to invest money in your tool and wants to enforce the use of your tool in the company?
Yes, so there is two different strategies you can get the tool into. And difficult tools, you normally have to go bottom up. You have to get engineers kind of interested in using the tool and ask their manager, can we buy it, right? Otherwise, it's not going to happen. But you need management in order to have it sustainable. So what we normally do is we have kind of a sales package that we give to the engineer and say, show this to your manager, right? And that works okay, not good enough though. So it's much better if you can make the engineer take you to management, because you're, after all, the best salesperson for your tool. And you know most about the context, etc. So we ask them to invite us for a discussion with management, and if we have had that discussion, we can see where it goes. But that's the better strategy I've found out. So in the beginning, we were just focusing on engineers, and that's fantastic, and those people really like it. But they also, they don't like to talk to their manager, and definitely not ask things to their manager. And if there's a hurdle, they would rather do something different than go that way. So you really have to make them part of the game, so to say, and that's difficult, yes.
Yeah, kind of a follow-up to the previous question here. So this specification language is a whole new language on top of the implementation one, right? So how hard it is to teach that to the industry people? Like, they need like a whole other universe to care about. It's probably more fun than writing tests, but it's difficult, isn't it?
It's extremely difficult to teach new languages to established industries.
No, I'm just asking how difficult it is.
Well, we fail and we succeed. It depends very much on the people you have to teach to. If what we say to management often is, don't let us teach this to your testers. It's too difficult. Not because of the language, but the abstraction level is very high. And if they have selected people that do not have such a high abstraction level and put them into the testing department, which I think is wrong anyway to have this distinction, but some companies do have that, then you're going to fail. So it's a tool which should be used by people that are used to programming and that like do new stuff. So you have to identify, is that in the company present? If not, we have to go another route, right? We have to.
So maybe people don't have like enough competence in the company to actually adopt this, and testing is better for them. I mean, more manual testing than this, right?
Yeah.
Okay. Thank you.
That could be, yes.
Okay, we'll do one more.
So, testing is a integral part of the agile process that seems to be rather popular these days, and that is done by programmers. Have you gone into environments where people are doing agile? Is there an easier uptake in that environment?
It's definitely easier to have an uptake in modern companies where people are not afraid of doing things differently, and agile companies definitely. I think Basho and Klarna are using agile methods to develop their software, and they have a better uptake, definitely better uptake.
Okay, we'll do the last one.
Okay.
Yeah.
So I know you guys have got Ulf on board at QuickCheck of Agda fame.
Mm-hmm.
Is he doing Agda just because he's really convinced that everyone should use dependent typing on greenfield projects and therefore avoid this whole fuzzy checking, or conversely, is there anything interesting that can come out of this? So I think both approaches are really great, but it'd be good if they were maybe somehow combined, or is this completely different?
It's not completely different. So Ulf works part-time for us and part-time for university, and that's his choice. He wants to do both things, right? He wants to maintain Agda and he wants to work for us. He likes both things. He's a very much a contributor to all those kind of fantastic ideas that we have implemented in QuickCheck. It's unrealistic to see the world move to Agda in a short term. It's a fantastic language. We all agree on that. But it's not simply, if we talk about difficulty in learning people new things, it's difficult. There's also a steep learning curve. So I haven't seen kind of the synergies too much to say, oh, let's do everything in Agda and the world will be better. So in order to serve the majority of people, we have to make it simpler, and not more Agda, right? That's the take we have.
Okay, let's thank the speaker.
Has an idea of why on earth academia and industry should talk.
I think in my work, I sometimes, so coming from industry, I'll read a paper and having more occasions, like it's like people go to WWDC to yell at the developers who make their life miserable, or like tell them like, and so having more opportunities to talk to academics who are writing the papers that perhaps influence my work, and be able to say, well, actually, what I care about is this. I really care about what you're doing, but also, perhaps this aspect would be really interesting. That does, I think that would be sort of an ideal scenario, and something that I do hope for.
I like that answer a lot, because it gives this interaction in a nutshell.
in the industry, sometimes people miss the vocabulary to talk about software. And I think this is the main reason why many developers just say, I like this, you like that, so let's stop discussing about it, because the vocabulary is missing to quantify and to describe software. And I would have loved to expand my and my teammates' vocabulary and have better chances of talking about software.
Oh, I like this vocabulary thing. I will come back to that in a slide in a minute. Anyone else, or shall I continue what I think? Oh yeah, oh sure. So we are, for those that are coming in now, we are answering the question, why on earth should academia and industry talk?
The only thing that I was going to say is we at Basho implement like CRDTs, which is largely an academic invention, and yeah, implementing this stuff is really hard. Getting it right is really hard. And yeah, we need to talk together. Like that's the only way we've been able to do any of this stuff and get any of it working. So.
Okay. So I jump forward then. So my main reason to do this, to say, why should we talk this? Because of innovation. Innovation is something that needs both partners. Innovation is not done in academia. That's for sure, because that's inventions which are done there. An invention gets an innovation if it is used outside, right? That's what we call innovation. So for the reason of innovation, we need to talk, and we need to go and talk to each other. And I will tell the story of one of such an invention. So I'm going to tell about QuickCheck, and not so much about the technical content of QuickCheck, although I want to do a demo and I hope that that will work, but more how we got from an invention to a product. So if you look at the website of Curion, then the main phrase there is academia and industry, they need to talk, right? And then the question is why, right? That's the obvious question. So this is the question from me to you. Why do we need to talk?
So that we stop doing so that we stop doing irrelevant research.
Okay. So that's
a joke.
Irrelevant research, right?
Oh.
Right.
In general, I think that a lot of good things are invented in academia that are widely ignored, and a lot of useful experience comes from people working in industry that we ignore. So, and then we could do more socially useful research or find better ways to apply the things that we've done if we have talks with the right people. That's my take.
Okay, that's a good take. Anyone else that wants to say something about this? Go into an innovation, and that's QuickCheck. And for you, those of you which have never seen QuickCheck, I will give you a very short introduction and then a little bit longer demo later on in the talk. So, QuickCheck, the idea of QuickCheck is that it is extremely boring to write test cases. Okay? That's something people don't like to do, and people do very poorly. And it's also, some part of it is creative, but a lot is very uncreative. So you want to move testing from this uncreative, kind of robotic job into something smart. And the way we can do that with QuickCheck is to generate your test cases automatically. So instead of writing, you have the computer make your test cases. That sounds fantastic. It comes with a price, of course. Nothing for free. The price is that you have to write a property. You have to say a property about your software. Like, the software should not crash. That's a property of the software. You can think of lots and lots of properties. I will show an example later on. But you write a property about your software. That property is now central for automatically generating test cases from. So this property is given to QuickCheck, and QuickCheck then says, oh, I generate a number of test cases, and oops, I have a failing test case here. So this test case generation is done on basis of randomness. There's a random process of creating data that fits this test case. You have random test cases, and one of those test cases may fail. Now, failing test cases are normally the things that testers really like, whereas developers prefer to have the non-failing test cases. That speeds up their work much better. So you have a failing test case, but since this is randomly generated, such a failing test case could have lots and lots and lots of data in it, or lots of things in it, which are not really relevant for making the property fail, but which are there anyway, because you have this random process. So what we do then is automatically simplify that test case to the simplest possible test case, a minimal test case that provokes a failure, right? So now you have your debugging. So normally if you get a log, for example, oh, something went wrong, my system crashed, here's the log. That's kind of brain dead, dumb work to go through the log and find out what has happened. Wouldn't it be fantastic if the log is automatically decreased to 5 statements saying, hey, this is where your program goes wrong. Now, that's what we do with QuickCheck automatically. And we do that in order to get the real signal out of the noise that you get when you put randomness in